Hi, everyone. Welcome to the Data Strategy Podcast, where we discuss everything in the world of data architecture, data governance, and data management. And I'm Dave Kruse, CEO of Augment, and we're a digital AI and consulting firm in Madison, Wisconsin.
And I'm John Hwang, Head of Data Engineering here at Augment.
All right. Thanks, John, for joining again. And so in our last podcast, we mentioned that we don't offer box software, but we do offer a boxed solution. But let's in this podcast, let's talk about more about box software around data, because we often hear from clients about the data platform software that they either bought or are looking at, and there seems to be kind of three categories that come up a lot, and that includes the all-in-one data platforms where you do everything on one vendor tool, and there's the data virtualization tools, and then the ETL tools. And so let's take those one by one, and let's start with the all-in-one tools. And so, John, what are they exactly, and what do you say? What do they say they can do exactly?
Yeah, so the idea here is that there is one tool that handles all of the elements of analytics, right? So that's your raw data store, your ETL, your data warehouse, visualization, often even AI, all done under the umbrella of this one kind of universal tool. A lot of them are handle the sort of applications that feed into the platform as well. So your front and back end, those tend to be specialized by usage. So there are some very famous vendors out there that sell this type of platform for like customer relationship management, for sales, for example. There are marketing platforms like this. Um, there are the other side of that is that there are some vendors that start with the analytics, but then also include all of the AI as well. So there are some that do like AI-based data and anti-fraud detection, right? And then they started that way and then sort of generalized into these all-in-one data platforms. So you'll usually see the data platform at the very least overlap with at least one of those two things, right? Either the applications on the front of it and or the AI on the other side of it. But the idea is that everything is happening under what appears to be just one tool, right? So it's just under one umbrella.
Okay. And before we really jump in, I just had a question on that, because it kind of sounds like you're talking about AWS or GCP, Google, but you're not. And so, like, what's the difference between these all-in-one platforms versus, like, let's say GCP, Google, which we like a lot?
I mean, GCP and Google both, I think, have maybe taken some inspiration from these kinds of tools, but the difference is that under GCP and Google, you have direct insight into where the data is stored. You have direct insight into the ETL. These are all, as well as the data warehouse, as well as the visualization tool. All of these things are still distinct tools that can be replaced with third-party tools at any point, right? And all-in-one software, it's just one tool. So the visualization, data warehousing, storage, you don't really get to control where all of that goes because it's all happening behind a black box, essentially.
Got it. Okay. All right. Thanks. That's helpful. And so, with these all-in-one tools, what are the kind of the main advantages?
So they're convenient, right? Certainly, even from like something as basic as like logistics, where you only have to write out one purchase order, right? They're convenient. It's just one vendor ultimately that you need to deal with. Um, Generally speaking, they tend to have a nice kind of GUI and front end, which I think the benefits of that are a little bit underrated in our line of work. Um, they will often provide their own IDE, so integrated development environment. So basically, a place to write out any code that you need to write out. So you don't need to sort of separate that. Doing that under the same umbrella as where your data is sitting can be quite helpful. It can make development go a little bit faster and testing a little bit easier. And it's ultimately it's easy messaging to your leadership to say, this is just one vendor, right? One vendor means, one contract to sign. It means you only need to make this decision once. There's only one point of contact. It makes everything sound simple, which can be a very easy way for clients to message this to their own leadership to be able to sort of sell the idea to them.
Got it. Okay. All right. Well, that sounds good. So then what are the disadvantages?
So I think starting off, right, is this idea of the all-in-one, right? The analogy that you'll hear a lot is that they're a Swiss Army knife. Um, the disadvantage is I'm not sure if you've ever tried to use a Swiss Army knife for anything, including cutting, but
Right.
it's awful, right? Like even something as basic as like a corkscrew, I would rather have a corkscrew than try to
Yeah.
use a Swiss Army knife. um, when using it as a knife, it's not balanced. And in fact, the fact that the blade isn't centered to the handle is a huge problem, right? Like a Swiss Army knife is not actually good at any of the one things it does. It just happens to do a lot of things. This is often the case with these all-in-one tools, right? And the problem is that it might not be the best data warehouse, let's say, but it doesn't matter. You're stuck with it, right? You had asked the question before about, what's the difference between this and going with one of the cloud hyperscalers. You on a hyperscaler on AWS, if you don't like Redshift, you can swap out Redshift for something else. On GCP, if you don't like BigQuery, you can swap that out for something else. Same with any of the sort of steps in all of this, right? Most of those things are replaceable with something else. Even if that something else isn't a third party, right? There's often another option within the hyperscaler. These all-in-one vendors, that's not a possibility because they can only work with everything happening under the one tool. This has some issues with lock-in. Now, on the data side of things, vendor lock-in is somewhat inevitable. This isn't quite like applications where vendor lock-in it can be avoided in some cases. That vendor lock-in with the data is to an extent unavoidable, but even when you have that lock-in, usually or I shouldn't say usually, but many of these platforms make it easy. Many of these all-in-one platforms make it easy for you to get your data in, but they make it very hard for you to pull your data out,
Right.
right? So,
Surprise.
so while vendor lock-in may not be as much of a concern in the data space because it's inevitable, data lock-in can be a significant problem, right? Um, They are also very expensive for each of the components. They tend to be more expensive on a one by one basis, which is a little bit counterintuitive. Usually, you would think that if it's all bundled together, each component will be cheaper, but you're generally going to be able to find cheaper alternatives for each component of that stack that I mentioned, the raw data storage, ETL, data warehousing, even the visualization. Um, it can be difficult to hire engineering staff because basically you have to hire staff that knows that one tool. And ultimately, in the long run, what that results in is a longer build time. If for no other reason than just it will be difficult to even staff enough engineers to be able to build at the pace that your business is demanding.
Gotcha. Okay. And all right. And what about the AI capabilities of these all-in-one platforms in general?
So this is this is often a big selling point for these tools, right? That the AI part, which can be kind of the most opaque part for leadership, is all under the same umbrella as your data. The problem is that you are usually limited to whatever pre-trained models they have, right? It can be difficult to use your own, in no small part because it can be difficult to get that data out, as I mentioned before, right? Using your own models requires training your models. And training your models requires access to the data that usually requires you to be able to pull that data out of wherever the data sits and into wherever your model sits. So if you're going to try to use your own models, that can be difficult in depending on the tool. Um, to be able to leverage models outside of whatever they're providing you. So you have to kind of hope that the models that they have are good enough for what you need. Um, the ul- ultimately, this fits into that Swiss Army knife, the Swiss Army knife analogy of, look, is this company the best at any one thing? AI is included in there. And often, though not always, the answer is no, they're not necessarily the best at the AI part of this. There are often better kind of whatever your definition of better is, whether that's literally the model is more accurate, or maybe it's just the model is cheaper, the model is easier to train. Those, better can mean different things to different people. And, you just have to kind of hope that this all-in-one vendor has the better model. They're usually not going to have the better one, though.
Okay. Yeah, and why is that? Why aren't they, yeah, any good in general?
Well, I want to be clear. I'm not suggesting that they aren't any good. It's just
Yeah.
they're not the best because ultimately that can't be ultimately that is usually not their one and only focus, right?
Okay.
Um, there are some exceptions to this, but usually the AI model is maybe not an afterthought, but it's certainly not something that they can dedicate all of their attention to, as opposed to using a third-party AI model where it might be, an open source model where there is an entire, online community dedicated to keeping that model up to date, or it could be an AI company where their, main and sometimes only focus is, a set of models that they have. So it's that Swiss Army knife thing of just,
Hmm.
are they going to be able to keep up with their AI competitors on their models? Oftentimes
Gotcha.
the answer to that is no.
Okay. Okay. And uh, we're almost done here with the all-in-one tool, but I was curious. Can you paint a bit of a picture of what a company could expect if they decide to go with one of these all-in-one tools, like at the very beginning, and as they kind of evolve and work in this platform, will performance get better? Will their life get easier? I imagine up front it might be easier, but yeah, how would that look, do you think?
I mean, I think easier sort of depends on what you're comparing it to. You had mentioned the hyperscalers before. Building a data platform on a hyperscaler these days, you know, with the proper experience, or not the proper experience, but if you know what you're doing with it, building a data platform on one of these hyperscalers is often as easy, or at least close to as easy as building it in one of these all-in-one vendors. And in fact, depending on how long it takes to install one of these vendor tools, um, easy or not, the initial build can often happen faster, right? So the all-in-one tools do have an advantage if you are literally just sort of buying tools independent of each other and installing it all on-prem. But if you're already in the cloud, the gap between installing an all-in-one tool or just building a data platform in the cloud is small to non-existent. And like I said, in some cases actually goes the other way. Over time, it is highly unlikely that you would see significant benefits related to cost. It is unlikely that you would see significant benefits related to performance. That one is very dependent on the vendor, obviously, but unless the vendor is using um, basically Spark, which would be the only thing they could use as their actual data warehouse, um, performance is not going to scale as well as a modern data analytics um, platform, whether that is, kind of one of these MPP databases, or whether it's something like Spark. Um, so performance over time usually is not going to be good. Cost over time is usually not going to be good. Build times can start to get delayed once, demand increases and you're finding it difficult to sort of keeping up to date in terms of your staffing. Um, so honestly, these tend to be decisions that over the long term, I've seen more clients than not come to regret because of those things. I think the initial benefits aren't so much about kind of an ease of build time, maybe as much as just, again, the ease of decision making, right? Which admittedly can be taxing for certain
Yeah.
clients. So it can be beneficial to just say we just make this one decision and we're done. But usually over the long term, whatever benefits might have existed tend to evaporate.
Okay. Well, you're really selling it. No, just kidding. But
Yeah.
who is there any company or where these platforms would be a good fit? These all-in-ones.
Honestly, I'm of the opinion that no, probably not.
Okay.
Um, I do think that, look, it's better than having nothing, and there are certainly some companies where their decision-making process can be so kind of encumbered,
Mm,
for various reasons, that it's either they make this one decision and buy the all-in-one tool or nothing, and it is certainly better than nothing, right?
okay.
The reality, though, is that other than that, probably it's probably not the best solution for anyone. The only other possible um, reason would be if you really need the tool on the application side. So if you really need it for, the CRM part, or the marketing part, or the sales part, or whatever, and you again just either can't make the decision, or uh, um, just for some reason you know can't build out the data part of it, right? Then, maybe then it would be better to do this. But again, it would be better than nothing. That's just another example of it would be
Yeah.
better
Yeah.
than nothing.
Gotcha. All right. Sounds good. All right. Well, appreciate that. So I think that's probably enough for the all-in-one platform. So the next tool I think on the list was the virtualization tools, which I'm excited about. I think there's a lot of misinformation um, around that, so kind of excited to dive into that. So, yeah, can you kind of describe what are these virtualization tools and what are they supposed to do for companies and clients?
Yeah, so, these are the tools where the sort of the marketing around them is that you can avoid having a physical centralized data platform, and instead you just build a virtual one, right? So rather than actually moving all of your data into a centralized data lake, or a centralized data warehouse, you have this tool, you connect it to all of your various source systems, and then you send it a query just like you would send it to a single data platform, and the tool sends that request over to each one of these source systems. It waits for the response from each of them and then collates the results and sends the results back to the original requester, right? So it gives downstream users and applications the appearance of a single kind of or centralized, I should say, data warehouse, without you having to actually kind of physically build one.
Okay, all right. And can you give an example, like a practical example of how this kind of works for a company? Um, yeah.
You install the tool, and
Okay.
then through that tool, you have to establish a connection to each of the databases. So just like you would do that in kind of whatever application that you would have when you're building out your a centralized data platform, you do need to connect this tool. So it's a connection string, that's a login ID, all of the things that you need to connect, to each
Okay.
of these source systems. So you have to set all of that up. Obviously, you have to install the tool as well, and then establish all of your users. And then there is this now one place that you can go Oftentimes the tool has some type of portal component to it where, you type in a URL, it gets you to this page, and some of them have a visualization component to them. Some of them you just type out the query in a
Okay.
window. But either way, you are uh, either directly or indirectly writing a query, and the results come back to you. So it looks like you're just querying one data
Okay.
warehouse.
And when you connect to these data stores, do you need to worry about the data schema, or can you just, is it more the credentials and you're set, ready to go, or how much work is it to like connect?
It varies a
To,
little bit on what the source system is and a little bit on the virtualization tool itself, but ultimately, yes, you have to be just as you have to be somewhat concerned about schema at the very least, because ultimately the virtualization tool needs to know how to query
okay.
these databases, right? So it does need to figure some way out to understand relationships between tables and things like that.
Okay.
So it's not just a kind of, a push button. It's on, you're connected, and you're ready to go. You
Okay.
usually need to establish some amount of metadata, quite a bit in some cases, to be frank.
All right. Well, that seems fairly easy. So yeah, what are the advantages of these virtualization tools?
Um, there are very specific scenarios where some amount of virtualization may be required, or I should say, may be beneficial. I have even before virtualization tools have existed even before the cloud days, and they made a lot more sense
Hmm.
than they do now back in those days. That's not to say they made sense, it's just they make more sense than they do now. By themselves, to be honest, it's I've never recommended for a client to have just a virtualization layer and nothing else. I do think that there is some room for virtualization if you already have a centralized data platform and you need quick access to a very specific database that you haven't connected to yet in order to do some analysis to figure out kind of um, what you might need to build due to kind of a new use case coming in. In a situation like that, it may be beneficial to have a virtualization tool, so that you don't need to migrate a lot of data in if before you can start analysis if it's a large database. To
Gotcha.
be
Okay.
honest, even in a scenario like that, I would find the benefits somewhat questionable, but I would say a situation like that, there may be some benefit in having a virtualization layer as an add-on to your centralized data platform.
Okay.
As
But
its
no,
own thing,
yeah.
I would say, there are probably not a lot of advantages you can actually think of. It's not actually faster to build. It's not actually any easier. Um, you know, it doesn't really even save you any time because most of the time consuming part, at least of an initial build, is actually getting those data connections.
Yeah.
So yeah,
Okay.
so the advantages I'd say are fairly slim.
Okay. So yeah, yeah. Keep going on with what are some of the other disadvantages with
So because you never actually store because you never actually store your processed data, you have to process it each time it's requested, right? So whether that is joining the data across multiple source systems or kind of, reconciling duplicates or discrepancies or anything like that, right? You have to do that each and every time you run a query, right? And this can slow a query down significantly in some cases. In some cases, it may only slow it down by, whatever, a couple of seconds. Um, in some cases, it's not even practical to do at all because it can make a query last hours, right? Which
okay.
no one's going to be okay with in this day and age. Um, Part of the problem too, in terms of query slowness, is that your query can only ever be as fast as your slowest source system, right? So whatever your slowest to respond source system is, your query has to wait for that system before it can send the user the results. So your queries are only ever going to be as fast as whatever your slowest system is. Everything is going to be held back by that system. And that can be a different system for each query. Um, this is also all very taxing to the source system, right? So in kind of a modern centralized data platform, you only ever hit each record once per DML statement. So that's once per insert, update, or delete, right? But in this model of virtualization, you're hitting it once every time a query is made. And with few exceptions, a record will be requested far more than it will have an insert, update, or delete transaction applied to it. And so it's very taxing to the source systems to be able to sort of constantly have to fulfill these hits that are happening against it whenever a query is made, right? Um, in some cases, this this uh, this implementation isn't even possible. So if you have data coming in from a third-party vendor, for example, they might not allow you to connect your virtualization tool to their data system, or they might not allow you to pull the data over and over again. Many third-party vendors basically give you access to the data once, and then you have to pay extra if you want access to it again. Um, for data sources that connect via API, it won't always be
Hmm.
possible to sort of easily translate a query into an API call, in which case you would have to sort of make a massive what's called a get in terms of API parlance, right? So basically what that means is that if it can't easily translate the request into a query that the source system can understand, it may be forced to pull a lot of data, maybe even an entire table, in order to figure it out. Depending on the size of that table, that might not even be feasible because you might run out of memory on the virtualization tool.
Got it. Okay. All right. But I'll go back and we kind of talked about it, and you said it's not a faster build, but it seems like it should be a faster build because you don't actually have to build anything necessarily.
This is one of the reasons why we advocate in our methodology building use case by use case instead of kind of going section by section across your data platform,
Mm.
right? So in other words, we don't advocate building your entire data lake first, then building your ETL process, then building your data warehouse, right? We always advocate pick a small use case, at least for the first use case, pick a small one, build your entire layer across. One of the reasons that we always say for that is because it means that feedback can happen earlier rather than later. It means that the user can see at least something that they can do something with earlier rather than later, right? Um, these these platforms can sometimes give the appearance of being faster to build because they can what they can provide faster is at least something to give feedback on,
Mhm.
right? That something may not be a complete build. That something may or may not even be necessarily useful, but they can give the appearance of being fast because there is at least something to that somebody could give feedback on early on, right? That tends to hide the fact that it is not necessarily a faster build, right? Again, a lot of the initial parts of a build to a new source system is just getting access to that database, right? That is a process that we have seen take weeks in some cases. If you're dealing with third-party vendors, that could take months as you're sort of negotiating a new contract with them. None of that really disappears because of this, right? Um, the the for situations where there is sort of complexity in how you need to process this data. So um, for example, complexity in how to join data across systems, right? Maybe you don't have the same identifiers for a customer in one system versus another, and you need to be able to reconcile that somehow in order to join the customer data across these systems. That's something that's going to take a long time. That's something that's going to take a certain amount of time no matter what. That is something that could actually take longer if you have to embed that into a single query as opposed to putting that into an ETL process. right? If there is any amount of complexity to the business logic that you need to apply, your build time could actually be slower using something like this. Um, Modern data platforms using modern build techniques, those can happen very quickly, right? Simple use cases we've seen under those types of circumstances can take hours. Even the complex ones tend to only take 1 or 2 weeks. Um, you know, Compare that to a virtualization tool. Will the tool save you some amount of time? Often the answer is no, but even in the cases where the answer might be yes, there are so many other advantages to just building out your centralized data platform. The centralized data platform is the builds can be fast if you apply these modern techniques. And so, is the trade-off really worth it? To the extent that it even exists, I would find that questionable.
Okay. All right, that's helpful. And you mentioned ETL. Can you expand a little bit on ETL with these virtualization tools? Like, can you avoid it? ETL.
I mean, I suppose just saying no and ending the podcast isn't an option here. Is the answer to that is no,
Sounds good
right?
to me.
Yeah, I don't know what this has always been a marketing element of
Yeah.
these virtualization tools, right? To say no ETL. ETL isn't required just because you're trying to centralize the data, right? ETL is required because your use case needs data from disparate sources, whether that's disparate tables, disparate databases, or in some cases even disparate systems. And that data needs to be able to talk to each other, right? So that is a business requirement, not a technical one. So changing the technology from a physical data platform to a virtual one doesn't eliminate that business requirement, right? So again, using the customer data example, if you have customer data across 3 systems with some of those customers overlapping, right? So, there may be some duplicates, let's say, across those 3 systems. How are you going to reconcile that duplication in a single query, right? The answer is you'll need to basically write a significantly longer query in order to do it. That hasn't eliminated ETL. You haven't eliminated everything. You've just moved it from one place, right? An ETL process that you run upfront to the data before it's queried, to the user side, which is probably where you can least afford to run something so complex, because however long that takes, that is time that the user is waiting for their data to show up in a report. And in this day and age, even a delay of a couple of seconds can be significant, and it can significantly impact user experience. So the simple answer is no. You cannot avoid ETL by using these virtualization tools. You've simply moved it from an ETL platform to your virtualization platform, and that usually means it's in the wrong place.
Okay. All right. But are these virtualization platforms, are they cheaper than data platforms?
If the virtualization, if the data platform, I should say, is the only technical expenditure that you have, then yes, right? So compared to building out a data platform, these virtualization tools are usually cheaper. But if you are paying for the source systems, or just paying for the data from these source systems, then no, these things usually aren't cheaper, right? You're taxing those source systems more because you're hitting them at every query. That is significant. That's not a minor thing, right? So just like with ETL, right? You haven't eliminated these costs. You've just shifted where they go. And in this case, you've asked the source systems to buy more database infrastructure, even though they don't need it for their applications, right? And they only need it because some virtualization tool has now been sort of placed on top of their database. And that can cause a lot of infighting between groups within an organization, as these source systems now have to bear this burden. the other thing about that is what is the sort of performance benefit you're going to get per dollar spent. If your source system is, and they usually are, meant for transactions rather than analytics, a dollar spent to improve performance on an OLTP database in order to accommodate OLAP transactions is usually a less efficient dollar spent, right? Meaning that you would have been better off spending that extra dollar on an OLAP database rather than trying to improve OLAP performance on an OLTP database. So ultimately, the costs overall usually are going to be higher using something like this. To the extent where they're not higher, what that usually means is that you've hit a very low performance ceiling. So you're not spending any more money, admittedly, but what you're doing is you're also getting a very low level of performance. And you simply can't spend any more money because you've hit a performance ceiling based on the infrastructure that you have.
Got it. Okay. That's helpful. Yeah, that makes a lot of sense. But all right. Well, that's probably enough on the virtualization tools. We could probably talk for hours more, but let's go on to the third and final tool that we'd mentioned at the beginning is the ETL tools. And yeah, so these used to be really important in the legacy data warehouse days. And these days they're still there, but they don't seem to be as big as they used to be. So yeah, John, what should people know about these ETL tools?
Um, so they used to be, and some still are, sort of black box systems that would connect to a source system, pull the pull the data from those systems, process it, then spit out the results into your data warehouse, right? This was usually all done via a GUI rather than writing code directly from a command line, and they usually um, sat on their own these tools usually sat on their own servers that and the data ultimately had to go through those servers um, before they hit the warehouse.
Got it. Okay. And just for context, like with the GCP platform or Google, like how does ETL play into that, or what? Yeah, how does
I
that
mean,
work? Yeah.
there the answer that GCP would give you is that there isn't necessarily just one way to do that. So they do have depending on whether you're talking about GCP, AWS, or Azure, they do each have at least one tool that they refer to as an ETL tools. Azure has Data Factory. Um, AWS has Glue. GCP has actually a couple of different things, but Data Fusion is one of them, for instance. Out of those three, Data Fusion is actually has a GUI to an extent. So does Azure Data Factory. So, but on any of those hyperscalers, you can also do ETL within the data warehouse, and that's generally the approach that we recommend. You can set up a Spark cluster and just do ETL there. Um, some clients choose to do ETL in their OLTP database, so like a Postgres database, for example, and so you can set something like that up in one of these cloud vendors. So you know the the answer varies a little bit depending on your vendor, but usually the answer is here's our primary tool that we think about when we say ETL, but there are all these other options for you as well.
Got it. Okay. Thank you for that. And but we're talking about essentially ETL standalone tools, right?
Right.
So yeah, what? So let's go back to that. So why were they so popular
So
back in the
I
day?
think it's important to sort of think about the context in which these tools came about, right? Because these tools have been around for decades, right? Back when they first came onto the scene, databases couldn't really handle the load of processing large volumes of data at once, right? At least not in kind of not at the same time as report queries were hitting those same databases, right? And so these these tools made it the fact that these tools were separate from the database was an advantage in a situation like
Mm.
that. Now you had your own dedicated server, your own dedicated tool to handle all of this data processing. You didn't need to do it in the same place where all the reports were running, and you could do it in in an environment that was specifically meant to handle large quantities of data, or at least data, in quantities that were considered large for the time. Um, the GUI based development, that the nature of the GUI based development made it easier to train people without having to teach them, a specific programming language, for example. Um, and at the time that these ETL tools came out, there really weren't a lot of programming languages that were designed to handle processing large volumes of data at once. And so in that type of environment, these tools became enticing just because of the performance that it could benefits that it could give you, because of the ease of development benefits and the ease of kind of ramping up and training benefits that an organization could have. So those were the types of things that generally led to organizations going with these ETL tools, at least traditionally.
Okay. And yeah, you mentioned the GUI aspects. Like, so did that really help with the build time, having the GUI?
I mean, I think it it's important to keep in mind what you would compare it to, given that at the time there were not sort of well established design techniques around building ETL using scripting or codes. I would say the answer to that is, at the time, yes, it was. Yeah. I would say that in this day and age, depending on how you design the code and architect the code, and depending on what code you're actually using, not necessarily, no, not necessarily today. But at the time, certainly yes. There was significant time savings that you could have by using a GUI interface rather than having to programming it program it out in like C or something.
Okay. And so now, where have these ETL tools evolved to? Like, what's a modern ETL tool look like now?
So a modern ETL tool now, I mean, some of them still apply these techniques. A lot of them now are just push down tools, right? Meaning that you build it in a GUI, it will generate code behind the scenes and push it down to kind of whatever platform you want. And that platform is usually an MPP data warehouse platform or Spark. Um, so um, there are still other components to an ETL tool that I think are, even as relevant today as they used to be. So, for example, the ability to do change data capture, right, against a source relational database, that's an important thing even today. So there are certainly elements like that that remain, but while some of these tools can do the ETL within its own server, many of these tools these days are pushing down your ETL job into code.
Okay. And what type of projects or companies or platforms should be using these ETL tools nowadays?
I mean, should be using, I think, uh, I think, is a complex term here, right?
Okay.
Look, I think as I said, the CDC element I think is still an important one. Now, most databases come with their own CDC tool. If you're
Oh,
on
oh,
the
what
cloud,
CDC? What does CDC stand for?
change data capture.
Yeah, thank you. Yeah.
Um, so most of them have, most databases come with their own CDC capability, because all it's really doing is just reading a log within the database. Um, every cloud vendor, if you're on the cloud, has their own CDC tool. Admittedly, they're not comprehensive in terms of what databases they can connect to, but that certainly exists. So the CDC component, I think, is relevant to pretty much anyone and everyone who doesn't, for whatever reason, doesn't want to use the tools the CDC tools that they already have access to. Um, in terms of the push down component, in terms of the actual jobs, You know, is that relevant? I think theoretically, yes, especially if you're relying on Spark. It can be difficult to find Spark engineers, and it may be easier to, or at least Spark engineers who are experienced enough to write ETL jobs directly into Spark. And so it may be easier in a situation like that to use one of these ETL tools to push down code in that manner. For what we deal with and what we recommend to clients, because we recommend SQL-based ETL inside of the data warehouse, for a situation like that, these tools, given their cost, don't make much sense, right? Because you don't usually need that push down for SQL. SQL is a relatively straightforward language to code in. Anyone and everyone who knows data knows SQL. And so, I don't know that those scenarios like that would be worth the cost of one of these ETL tools.
Okay. All right. Well, thanks, John. I think that about does it. Is there anything else you wanted to mention, John, or summarize, or should we shut down this
No,
podcast?
I think that should be it.
All right. Well, yeah, I really appreciate it, John, and I hope all all your audience enjoyed it as well. And we appreciate your time, and we'll see you next time here on the Data Podcast. Thanks, everyone. Bye.